over 7,000 acres of national forest, private land, and ecosystems are destroyed to this devastating and predictable occurrence every year. Our system, which is based around the United Nations 17 Goals of Sustainable Development, seeks towards a solution to this problem and a brighter, safer future for our planet.
When we first started out on this project, we had to take multiple considerations into account when deciding on a product. We found that firefighters use robots to withstand high temperatures to fight fires rather than having people be exposed to that danger. They also have cameras located around that use infrared to find fires, as well as strategic watchtowers placed around New Jersey. However, as you may have noticed, these were all solutions to fires that have already started. So we decided on a risk assessor that is placed in a non-intrusive position, will not affect wildlife, and is used to predict the risk of a wildfire. This risk assessor will also be using a point value algorithm. A point value algorithm is a system of measurement that uses sensor data or environmental factors to output a number, which will then be used to determine the risk of a wildfire. Our devices would also be able to connect wirelessly with each other through a radio frequency. Thank you.
Our device takes in information from the sensor of the transmitters and sends it to the receiver, where it's outputted every 1.25 seconds. When the device senses that the temperature is too high or the humidity is too low, the device begins to beep, signaling that the risk of a fire is relatively high. This process is relatively simple, as our device uses a DHT11 temperature and humidity sensor, as well as an NRF24L01 radio module. In the beginning of our prototyping process, we used an outlet to power our device and a computer to output our data. However, we realized that this was impractical, and so we instead moved to using an LCD display and a 9-volt battery to power the module. This gives us the chance to transmit our signal and our data from up to 1 kilometer away from the home station. This battery may need to be changed frequently. So in the future we plan to use alternative technology, such as in the form of a solar panel, which will give us the chance to use this device for an indefinite period of time. This means that our device will also further be more environmentally sustainable. So we actually brought our prototype here today. Alec has the transmitting module, which will be somewhere in the forest. He's gonna blow into the humidity sensor, which represents a severe environmental change. As of right now, we have the threshold for the humidity set to 50%. So when the humidity percentage rises above that, it will begin to beep. In the future, we can change this so it detects the higher temperature or the low percentage of humidity. But as of right now, we have it set to high humidity for testing purposes.
Thomas Edison once said, "Anything that won't sell, I don't want to invent. Its sale is proof of utility, and utility is success." Our main target audience for the distribution of this device will be park rangers for national park use, or managers of major forests or wood protection units, so that they can utilize it and detect the possibility of a wildfire starting. This product will revolutionize the methods of predicting wildfires, and if used on a large scale, could save the homes and lives of many. Furthermore, our product is very unique and is the only one of its kind. Many of the existing products on the market are solutions only after the start of a wildfire, whereas our device predicts the risk of a wildfire before ignition. Our product is also very sustainable, as it uses 3D printed parts, inexpensive electronics, and alternative energy. This means that it's very low maintenance and user-friendly to implement. The cost is roughly $30 per unit. This price can be decreased through wholesale in the future, and also sustainable parts as time goes on.
Our system is easily customizable for different uses. Our subject matter experts indicated that out in Oregon, our system can be used to know when to stop lumber operations due to environmental changes, and in New Jersey and California, it can be used to predict wildfire probability and allow precautionary measures to be taken. Multiple devices will be used in the web to talk to each other, extending our range and localizing problems. We will implement weather data for wind direction and speeds to create graphs for long-range predictions and put our device in a more weatherproof casing. Our world is limited. and we must protect what we have. This system, a direct result of Thomas Edison's finding out what the world needs and going ahead and inventing it, will help us sustain what we still have. Thank you.